Hello everyone. In this video, we will show how to load and use a FreeSurfer Cortex in source analysis in Curry 9. So I will open a study and then insert the T1 MRI in FreeSurfer format. So I will look for it. It is already there, MRI, and this is the file that I'm looking for, T1, and insert it. Note that I require this for loading FreeSurfer created surfaces. So I will just go through the image data parameters and import the data. Now, what I need to do is to change the coordinates to FreeSurfer coordinates. So to change this, I just select this option. And now I can go to results and add the FreeSurfer Cortex. I will go to the surf folder, choose to see all files, and I need to import this one, the right hemisphere, and then Curry is asking me if I have already added the T1 MRI, which I have already done, and I have already set the FreeSurfer coordinate system. So I have already done these two steps, so I can press OK. I could add at this point intensities, but I will not. And I will add the second hemisphere, which is the left hemisphere. So I will add it. And now Curry will read the FreeSurfer Cortex. This takes a minute. Now that Curry has loaded the surface, we can inspect it quickly in 3D view and then go back to image data. In the results, we can see the FreeSurfer object in the surfaces group, and then we can now add this as a net. So let's import it as a net and now see that stop markers have been added delineating the cortex, and FreeSurfer segments the hemispheres independently. We can save some time in Curry by segmenting everything at once, and for doing this we just need to create we just need to erase some of the stop markers so that the segmentation can go through this region. And so let's go to image data, markers, delete stop markers, choose a sphere, and then I will just delete these stop markers. Now there's a connection between both hemispheres, and I can now segment using region growing. First, I will turn off the markers and use a segmentation of 1 to 256. Place the image data cursor somewhere inside the brain and press start. And this will create a segmentation using these markers, which were extracted from the FreeSurfer surface. At this point, we can save this segmentation by using create segmentation mask, and this will be shown here in segmentation mask. We already have saved this result, and now we can go to image data 1, open the BAMFAM geometry, and take a look at some of the options. We will create a BAM. Let's open the advanced option. We can use existing result as Cortex, so let's do that. And then let's also change the resolution to specify, because we want to increase the resolution of our Cortex in order to have a very similar result to what FreeSurfer delivers. So for the Cortex, we will specify a resolution of 1 millimeter. And this is it. We can now press start, and Curry will use the segmentation, which is this one, the Cortex segmentation, for creating a BEM head model. So after a few seconds, we will be able to see this model and also use it for source reconstruction, which I will show you as well. Creating a high resolution Cortex takes a couple of minutes. All right, so we are done. We can visualize the result in 3D view. I will now stop showing the FreeSurfer surface, but now show the skin. Well, this is the low resolution from the BEM, but there's also a high resolution skin here, and also the Cortex from Curry. We can also make it look even more realistic if we show the pile surface. So this looks quite good. And what we can now do is add a functional data file and run some source reconstruction. I will use this one file from other study, so it doesn't matter that it doesn't fit this patient, but it will just be to show you how you can do it. And now let's change to all. So now we have this one spike. Let's choose the peak of the spike, and let's choose the model that we just created, which is the very last one. Bam. Let's also choose source locations. Let's choose the Cortex that we just created, the Cortex manual 1 millimeter as our source location, and then run an Slrda current density reconstruction. And here we have it. Let's go to the 3D view. We have computed a current density reconstruction using the nicely resolved Cortex. So thank you for your attention.